Before we start with example 1, let's take a look at the graphs up on the top. So today we're going to be graphing logarithmic growth functions and logarithmic decay functions. If you take a look at this graph, some things to recognize with your exponential growth function is you do have an asymptote at x equals 0, or the y-axis. So you will see that asymptote here. And that asymptote will move with our translations if we move our graph left or right. If we move it up or down, that asymptote is going to stay where it's at. Unlike exponential functions that always had the point 0, 1, log functions are the inverse. So you can, when you find the inverse, you basically are switching that x and that y, you're switching the domain and range. So instead of that point 0, 1 that's always on your exponential functions, you're going to have the point 1, 0, whether it's exponential growth or decay. That will always be that original point. Then let's go ahead and take a look at example 1 on how to graph. So we've got the function g of x equals the log base 3 of x. And the first thing I want you to note is when we're picking x values for our table of values, you want to choose an x value that is a power of the base that you have. And our base that we have is 3. So we want to choose an x that's a power of the base 3. So we're going to choose an x that is a power of 3. And again, whatever your base is, that could change. So if your base was 4, you'd choose a power of 4. If your base was a half, you'd choose a power of a half. Okay, so then let's go ahead and take a look at this function. So I want you to think about what values that we're going to choose. So if I'm choosing powers of 3, we could do 3 to the first power. So we could choose 3 as an x value. We could choose, maybe do 3 to the second power. That's 9, so we could choose 9 as an x value. If we do 3 to the third power, that x value would be 27, and that would be off of our graph. So now we can also go into the other direction as well. So we can think of 3 to the 0 power, well that's 1. And then maybe 3 to the negative 1, which is a third. These are all points, all x values that we can find the log of because of our base. So you always want to find powers of that base that you have. And then what we're going to do is we're going to plug them in to here. So we get y equals the log base 3 of 3, and we're evaluating that. So the log base 3 of 3, you're thinking to yourself, 3 raised to what exponent is going to give me 3? And that would be 1. So that gives me the ordered pair, 3, which is what I had for x, comma, 1, which is what I just found for y. If I do 9, I'd have y equals the log base 3 of 9. So now I'm thinking 3 raised to what power is going to be 9? And that's going to be 2. So I have the ordered pair 9, comma 2. If I do 1, I get y equals the log base 3 of 1. So now I'm thinking 3 raised to what power will give me 1? And that would be 0. So I have the point 1, comma 0. And then the last point that I can do, I have y equals the log base 3 of 1/3. So now I'm thinking 3 raised to what power will give me a third. And if you remember from the last day of notes, if we go from a whole number to a fraction, then we know our exponent has to be negative. So we basically just want to move that 3 to the bottom of our fraction, which gives us a negative 1 as our exponent. So we have the point 1/3, negative 1. Then we're going to go ahead and graph that on our graph to the right, starting with our asymptote. Since we're not shifting anything here, like we said before, that asymptote is going to be at x equals 0. So I'm going to get my dotted line here at x equals 0. And then I'm going to plot my 4 points. I have the point 3, 1, which is right here. The point 9, 2, which is right here. The point 1, 0, which is right here. And then 1/3, negative 1, which is just an approximation here. So what's going to happen is my graph's going to come this way. And then it's going to come down and right as close as I can to that asymptote. If you have questions on this graph, let me know.